This video presentation is a look at a century of change on the Lyman Glacier, which I've had the privilege of visiting 13 times in the last 25 years. Now, the Lyman Glacier, if we look back to 1921, a mountaineers expedition went into the area, and you can see a view of the glacier, lake in the foreground, and then we have a view of the glacier 2008. Different lake in the foreground, same type of viewpoint, but obviously much shorter. Here we have points X, Y, and Z labeled 1921 view from on the glacier looking down valley. The same points 2008 looking down valley. A whole series of lakes evident in 2008. The lake in 1921 is way in the distance by the letter Z. Here we have another same view, 1921, looking down, straight down valley, and 2008 looking down valley. This is a different lake in 2008. The lake seen in 1921 is in the distant foreground on the left. Here we have just a different view from Cloudy Pass area of the glacier, 1972 below, 1921 above. The arrows are indicating lake locations, the Little Ice Age margin in blue, in red the 1921 margin, and then peripheral area of the glacier. Here we have a view from Cloudy Pass, 1921 above, 2005. Notice how much smaller the glacier is confined beneath the north flank of Chihuahua Peak in 2005. Just a shell of its former self. And then in the next set of images we have 1979 above from the Cloudy Pass area versus 2005. 1979 from Austin Post. Again, the glacier is much reduced from 1921. And we have the look at the whole glacier. The outer blue line is a Little Ice Age margin, green line 1920 margin, red line 1950s, and then the orange is the current margin. So 80% of its area gone. These arrows, the horizontal blue shows the Little Ice Age, the vertical blue shows the 1920, the 1930 margin is in red, the green arrow horizontal 1970, and then 1986 is the vertical green arrow for the terminus of the glacier. Vertical look 1972 2000, just to see the difference from this perspective for the Lyman Glacier. You can see not much of a lake evident in front of the glacier in 72. Close-up views of the glacier, just a few different years. 1986, big debris pile at the end from a 1930s avalanche. By 2000 it's fallen somewhat off the front, and by 2008 it's totally gone from the front of the glacier. Now the peripheral areas have really shrunk. There used to be a connection in the below picture between the upper Lyman and lower Lyman Glacier. Now the rocks are well exposed. And then we're looking at the snow slopes in the upper image, and that's not connected. Terminus Ice Cliff, 24 meters high above the waterline in 2008 here. Back in 1986 it was only 12 meters high. And then just views of the glacier in 2008. You can see it's just a little pocket glacier, 400 meters long on average from the front to the back. Now glaciers respond to climate change. If you have a negative mass balance, you're out of the equilibrium, you try to retreat to reestablish it. If you have a positive balance, you try to advance to establish it. Now if a glacier cannot retreat to a new point of equilibrium, it's in disequilibrium, and it will thin in the accumulation zone. It won't have an accumulation zone. So if we want to forecast the survival of Lyman Glacier, it has significant marginal recession in the accumulation zone. It's thinned, and so we would forecast that it will disappear. This doesn't tell us the speed, it just tells us that it is thinning and will. So if we look at the retreat rate, it's retreated about 10 meters per year for a long time. It hasn't deviated a whole lot from this. It's lost a third of its length since 1986. Given that it's 400 meters long, it will take 40 years then to retreat, if we extrapolate. Now if we look at the area, its area is 0.28 square kilometers now. It's had a reasonably consistent rate of area loss the last 50 years, losing half of its area. If we continue at this rate, we're gone in 50 years. Here's a diagram showing the decline in the area between the total glacier, the main glacier, and the peripheral areas of the glacier. And you can see how much is lost. And we can also look at the volume. Volume 17.6 million cubic meters. We can look at the thickness of the glacier at the terminus. We know the slope of the terrain, figure out the volume, and it too will be gone in about 50 years according to this volume loss. That's if we continue the current rate, which is with the current climate. And so you can see we're just extending these lines out. So depending on how you calculate it, you come out with 40 to 50 years of survival with the current climate. And this is just a map again reminding us of the different terminus positions through time of the Lyman Glacier. Now we go on these glaciers every year. We're assessing the mass balance of North Cascade glaciers. We've done this every year for 26 years with our boots on the ground, so to speak, measuring ablation, weather conditions, the snowpack depth here. We're probing for snowpack depth. You can also ascertain snowpack with crevasses. The green arrows show individual storm events. The blue are annual horizons, so it's like reading tree rings to get the snow depth. So we've done that for 26 straight years. Here's the curves of all North American glacier mass balances over the last 25 years, and you can see very similar trends, all downward. The Lyman Glacier is worse than this trend. And not all glaciers with negative balances are retreating. And finally, a view underneath the disappearing Lyman Glacier.